Hello everyone, in this video I want to show you how to write a MATLAB program that solves the given equation using Newton-Raphson method and also gives such a table with the following data when we run the program. So this is the basic formula of the Newton method. In this case I want to solve this equation right here. In order to do that, first I have to define the function, the derivative of the function, the initial guess, the tolerance, and the number of decimals. Here I want to provide the number of decimals as the inputs because they want different number of decimals in different problems. So let's do this. Note that I'm not gonna define any outputs here because all I want is the table. I can find anything I want in that table I showed you earlier. So now that I want to define the inputs, f is the main function and the initial guess, the tolerance, the number of decimals, and also I have to define something such as the maximum iteration. When I don't get to my desired tolerance and the program keeps running and does the iterations many times, for example, I don't want the program to do more than 100 iterations, so I'm gonna put the maximum iterations in 100 if I want. That's what the maximum iteration is. And note something important here. The thing is, I don't want to take the derivative of my function by myself. I want MATLAB to do that. And with the fact that the function handle won't work with the diff function. Diff function is the function which takes the derivative of the functions, and also the fact that my function has to be in the function handle type, so I'm gonna use the MATLAB function here. So yes, all the MATLAB function does is it converts the symbolic function, which is capital F, to a function handle, which is a small f. And here I'm gonna define my derivation of the function. It also has to be in the MATLAB function type. So note that you have to define the capital F, which is the input in the symbolic function. Because of that, I'm about to define the number of decimals as the input. I have to first create an string. I'm going to show you right here. So I'm going to define a variable named float. Here is where usually we put the number of desired number of decimals. For example, if I want 3 number of decimals, I used to put a 3 here. But now, because I want to define the number of decimals as the input, I'm gonna put this thing here. So remember that our table header had 6 data, so now I have to define such a string to have exactly those 6 data like this. And now I'm gonna just print my table header. So now that we have kind of created the table, we should just go and solve the equation using the Newton method. In order to do that, I'm gonna write a for loop and give it a variable iteration which is equal to 1 through the maximum iteration. And I'm just gonna write the equation here, which was the new x equals to the previous x and minus this. All it does is it just prints the data which will come from here, and it will just print the data below this table header, and yes, it just goes on like this. And also I want the program to stop immediately whenever I got my desired tolerance. Yeah, and right here, if we didn't get the desired tolerance here and the program didn't stop, we just have to update our initial guess to run the program over and over again until we get the desired tolerance. And yes, just end the program here. So now let us run the program and see if it works properly. Okay, so let's first define the inputs. So as you can see, the program runs properly, and note that all the numbers are calculated till the third number of decimals. Here, for example, if I wanted to do the exact thing, but with for example 6 number of decimals, all I have to do is just put 6 here, and you can see that the program calculates the data till the 6th number of decimals. And I think I chose my initial guess close to the 0 it found here. Let me just pick some point a bit farther, like what if I put it like 5 here. You can see the program runs, the program does more iterations like this.